one thing that comes up when you start talking about applications of derivatives is what type of problems do we have? And there's quite a variety of types of problems that you can come across. The first one that we're going to talk about that's in a major way, that's not so much about the method of derivatives, although that comes up here as well, is called related rates. So if we have a name for it, we need to know what that name means. So we're talking about two rates of change are called related rates, as stated here, if the original quantities are also related. So, well, what does that mean? So I think the best way of looking at it is to think about an example of what I'm talking about. How can two things be related rates? So think about air is pumped into a balloon. This is kind of a classic example. And let's say that the rate, the balloon's volume increases at the rate of 100 cubic centimeters per second. Okay. So now there's some key words in here that you should already be thinking about whenever you think about related rates. You see at the rate. So they're already saying there's a rate of change in there. Also, another key word is going to be increases. And a final thing to sort of say, to know that you're talking about a rate, is notice the units. So really important whenever you're talking about applications is to look at the units here. It's centimeter cube per second. So you know they're talking about a rate of change in some way. So we are in calculus. We've thought about it for a while. So we know what that is. It's going to be a derivative. So then how fast is the radius of, and let's say the balloon is spherical. So I forgot to mention that earlier. Increasing when the radius is 50 centimeters. So this is a pretty sizable balloon. If you think about it, that's half a meter. So that's a pretty good sized balloon. All right, so basically we start off with some volume increasing at a certain rate, and we want to know how fast is the radius increasing. So there's a couple things going on. So basically the idea is we have a volume increases at the rate, and whether it's increasing or decreasing makes a big difference. If it was decreasing, that would indicate a negative sign was going to be needed. And then you talk about how fast is the radius increasing. So you want to make sure you look for key words that are going to help you figure out, like, oh, that might mean a rate. How fast is something increasing? So it's increasing at a rate. So that's kind of important to think about when you're talking about it. So we're given in our way that the rate of change of volume, and it's, you notice the units are centimeter cube per second, and volume could be in centimeter cube, and the time could be in second. And so we're given that that is going to be 100. And if you want to put the units, you can. At this point, it's not quite necessary yet, but it can be very helpful. And then the question is, what do we want? We want the rate of change. Oops, I want to change that to black. So we want how fast is the radius increasing. So that's a rate of change of the radius. And it's time because it's talking about how fast it's increasing. And we don't know what that is yet. We're asked how that is. So I'm just going to put a question mark. You don't have to put a question mark. You could just say, I want, I want something or other. And then it says when it's 50 centimeters. So you can say R equals 50 centimeters. Okay. So now they're there, but how do you know that they're related to one another? Well, the definition says two rates of change, and we have two rates of change, are related if the original variables are related. So if it says a spherical balloon, so how is volume and its radius related? Well, we've seen something like this before, or I hope you've seen something like this before, maybe not in this class, but the volume of a sphere is 4/3 pi r cubed. So this means that the volume and the radius are related through this equation, through this formula. And therefore, the derivatives must be related rates as well. So